Hello, and welcome to episode 9 of the Kalopa Mission Control Podcast. I am your host, and it is a profound privilege to welcome you back to our quiet, observant corner of the maritime world. Whether you are listening to this while watching the rain draw intricate patterns on a window pane, or perhaps feeling the steady rhythmic rumble of a train beneath your feet as you commute home, I invite you to take a moment for yourself. Let the noise of the day simply wash away. In a world that constantly demands our hurried attention, this podcast is designed to be a sanctuary of time. Here, we measure our progress not by the frantic ticking of a clock, but by the slow, eternal breathing of the tides. We gather to track the meticulous engineering of Kalopa robotics and to marvel at the vast, complex, and deeply beautiful expanse of our blue planet. If an extraterrestrial civilization were to arrive on Earth today and dip a scientific probe into our oceans, what exactly would they find? For a long time, when we thought of ocean pollution, we pictured the visible, a discarded plastic bottle drifting on the current, or a tangled mass of abandoned fishing net washing up on a pristine beach. But the ocean is vast, and it is a master of dissolving and hiding our sins. Recently, a truly landmark study was published in the journal Nature Geoscience. An international team of researchers analysed over 2,300 seawater samples taken from across the Atlantic, Pacific and Indian Oceans. They were not looking for floating debris. Instead, using advanced mass spectrometry, they looked at the very chemistry of the water itself, specifically the dissolved organic matter. What they found was both fascinating and deeply humbling. Human-made compounds, what scientists call xenobiotics, are no longer just trace pollutants drifting through the water. They have become fundamentally woven into the ocean's chemistry. From agricultural pesticides and industrial flame retardants to the chemical additives that slowly leach out of degrading plastics, these artificial molecules were detected across multiple ocean basins. Naturally, the chemical signatures were strongest in coastal estuaries, where the runoff from our cities and farms meets the sea. But as the researchers looked further offshore, into the deep, remote open ocean, the chemicals did not disappear. The concentrations dropped, certainly, but the human fingerprint remained. The invisible phase of plastic pollution, where materials break down into microscopic fragments and eventually into chemical solutions, means that the legacy of our industrial age is now part of the very water column that sustains life on Earth. It is a sobering thought. We are changing the fundamental recipe of the ocean, and we are only just beginning to understand what that means for the microscopic phytoplankton and the vast carbon cycles that regulate our global climate. Yet, the ocean is not merely a passive victim of our chemistry. It is an ancient, dynamic system of unimaginable resilience. Even as it faces these invisible pressures, it continues to pulse with life, offering us moments of breathtaking wonder if we only know where to look. In the warm, shallow waters off the coast of Cambodia, in the Rong Archipelago, conservationists recently witnessed something truly miraculous. For the third consecutive year, they documented a mass coral spawning event. If you have never seen a coral reef spawn, it is one of the most spectacular phenomena in the natural world. It is a highly synchronized underwater snowstorm. Guided by the temperature of the water and the cycle of the moon, entire colonies of coral simultaneously release millions of tiny buoyant bundles of eggs and sperm into the water column. These bundles float slowly toward the surface, a beautiful fragile cloud of future life, hoping to cross-fertilize and settle on new areas of the reef. The fact that this is happening in Cambodia is a powerful testament to the resilience of the ecosystem. It proves that when we give nature even a small reprieve, when we implement local fishery protections and manage our coastal impacts, the ocean will fight back. It will attempt to heal, to rebuild, and to seed the next generation of reefs. To help the ocean heal, we humans are increasingly trying to draw better, smarter maps. We are trying to identify the exact nurseries and highways that marine life relies upon. In Australia, marine scientists have just completed a monumental 5-year project to map 158 important shark and ray areas, or ISRAs. By synthesizing decades of satellite tracking and acoustic telemetry, they have identified the precise critical habitats where endangered species like the scalloped hammerhead and the grey nurse shark go to breed, feed and nurse their young. It is a desperate science-driven attempt to create a lifeboat for species that are teetering on the edge. But drawing lines on a map is only half the battle. True marine protection requires a deep, abiding respect for the people who actually live alongside these waters. In Kenya, a beautiful shift is occurring in how we govern the sea. For generations, the Bajuni people of the Lamu Archipelago have read the colour of the water and the rhythm of the tides. They possess a sophisticated, unwritten code of conduct regarding their fishing grounds, knowing exactly when to leave a reef alone to recover and understanding the complex migrations of pelagic fish. For decades, modern conservation policy often ignored this wisdom, favouring top-down, fortress-style marine parks that alienated the very communities who had stewarded the waters for centuries. But today, marine biologists and government officials are finally integrating this invaluable indigenous knowledge into their scientific models. They are realising that the elder fishers hold generational data that remote sensing satellites simply cannot capture. By shifting to a co-management model, where science provides the framework and the local community provides the on-the-ground real-time enforcement, Kenya is charting a new equitable path for the blue economy. It is a reminder that to protect the ocean, we must also protect and empower the coastal cultures that depend upon it. When we consider these vast interconnected challenges, from measuring the invisible chemical pollutants in the deep Atlantic, to monitoring the quiet, triumphant spawning of a coral reef in Cambodia, to guarding the newly mapped shark nurseries off the coast of Australia, the sheer scale of the ocean becomes overwhelming. We simply do not have enough research ships to keep watch over the entire blue planet. This is the exact problem that Kalopa Robotics was founded to solve. If you were to step into our mission control room today, you would find the lights dimmed and the telemetry screens dark. We currently have no active missions at sea. Our fleet of autonomous surface vessels is resting quietly in the workshop. They're dry, their solar arrays are being polished, and their internal circuitry is undergoing rigorous diagnostic testing. While our boats are in dry dock, we are given the opportunity to reflect on the immense engineering challenge of robotic sailing and the history that has brought us to this point. At Kalopa, our chosen vessel is the 2.4-metre autonomous sailboat. To put that in perspective, 2.4 metres is roughly 8 feet. It is a boat shorter than a standard family car. Yet, we ask this tiny silent machine to survive in an environment that routinely destroys massive steel freighters. To understand how a vessel this small can conquer the open ocean, we must look to the rich and varied history of the Microtransat challenge. The Microtransat is a transatlantic race for fully autonomous boats. It was conceived nearly 2 decades ago by a group of visionary academics who wanted to stimulate the development of maritime robotics through friendly yet fiercely unforgiving competition. The rules are simple. Build a boat up to 4 metres in length, program it to sail entirely on its own, and send it across the Atlantic Ocean. Teams can choose to sail west to east, from North America toward the coast of Ireland or France, or east to west, riding the trade winds from Europe toward the Caribbean. The history of the Microtransat is a magnificent chronicle of human ingenuity, punctuated by the brutal, uncompromising reality of the sea. Over the years, teams from universities, naval academies, and private garages around the world have carried their small, brightly painted vessels down to the slipway, pushed them into the surf, and watched them disappear over the horizon. For the engineers back in the lab, tracking a Microtransat attempt is a uniquely psychological experience. You are entirely helpless. You sit in a warm, dry room, staring at a computer screen, waiting for an Iridium satellite ping that comes perhaps once an hour. You watch the digital breadcrumb trail as your little boat navigates the Gulf Stream. You see the telemetry data indicate that the wind has picked up to 40 knots, and you know, with a sinking feeling in your stomach, that out in the darkness of the mid-Atlantic, your 2.4-metre creation is being thrown down the face of 20-foot waves. You cannot reach out and trim the sail. You cannot adjust the rudder. You can only trust the code you wrote, the epoxy you cured, and the watertight seals you painstakingly inspected months ago. Many boats have been lost to the abyss. Some have simply vanished, their tracking beacons going dark in the middle of a winter gale, leaving their creators to wonder if they were crushed by a rogue wave or struck by a passing cargo ship. Others have drifted helplessly in the doldrums for months, their solar panels covered in a thick green layer of marine algae, completely starved of power. A few have washed up on distant shores, barnacle-encrusted and battered, to be found by bewildered beachcombers. But every failure in the Microtransat has been a gift to the industry. It is a crucible that burns away bad design. Through years of shared knowledge and collective trial and error, the community has learned how to build a boat that doesn't just fight the ocean, but yields to it. We have learned to design self-righting hulls that can be repeatedly rolled 360 degrees in a breaking wave and pop back up like a cork. We have learned to write intelligent, power-saving algorithms that teach the boat to go to sleep when the sun goes down, conserving enough battery to keep the navigation compass alive until the dawn. The 2.4-metre Kalopa boats sitting in our workshop today are the direct descendants of those brave early Microtransat pioneers. We build them small not because it is easy, but because it is necessary. A small boat requires no heavy lifting equipment to deploy. It can be launched from a beach in Kenya by a local fisheries officer or deployed from the back of a small coastal patrol boat in Cambodia. Powered entirely by the wind and the sun, it emits zero carbon and makes absolutely no noise. Imagine a fleet of these silent sentinels deployed to protect the ecosystems we have discussed today. A Kalopa boat could be programmed to autonomously patrol the boundaries of Australia's newly mapped shark and ray sanctuaries. Equipped with passive acoustic hydrophones, it could listen for the high-pitched whine of an illegal fishing boat's propeller, instantly beaming an alert via satellite to local authorities. It could sail slowly through the convergence zone off the coast of West Africa, carrying miniaturized mass spectrometers to continuously sample the water. It could map the invisible chemical plumes of wastewater and pharmaceutical pollution that we now know are fundamentally altering the ocean's chemistry, providing marine biologists with the high-resolution, real-time data they desperately need. Or it could simply loiter above a remote coral reef, serving as a vital communication relay between deep-sea sensors and the cloud, watching over the reef as it miraculously spawns under the light of a full moon. These tiny robotic vessels are not meant to replace human stewardship. They are meant to extend our reach. They are the tireless, unblinking eyes and ears that allow us to honour the commitments we have made to protect 30% of our oceans. They are the tools that will help us blend the brilliant ancestral wisdom of coastal communities with the cutting-edge data of the 21st century. To build a machine capable of surviving the open ocean requires more than just technical skill. It requires a profound poetic respect for the maritime environment. You cannot engineer your way out of the ocean's power. You must design a vessel that dances with it. Our engineers spend their days obsessing over the aerodynamics of a rigid wing sail, ensuring it provides maximum thrust in a gentle breeze, while allowing the wind to spill harmlessly away during a gale. They meticulously waterproof every electronic connection, knowing that the corrosive, relentless bite of salt water will find any weakness. They write code that teaches a machine patience, the ability to power down and drift quietly when the wind dies, waiting for the breeze to return. It is painstaking, often unglamorous work, but it is driven by a deep, abiding sense of purpose. The ocean is the life support system of our planet. It provides every second breath we take. It regulates our climate, and it houses a diversity of life that borders on the miraculous. From the majestic, migrating blue whales to the tiny, brilliant coral polyps building reefs in the dark. As our understanding of the ocean evolves, and as the threats against it multiply, from the invisible chemical pollutants in our water column to the relentless pressure on our shark populations, we must evolve our methods of protection. We can no longer afford to be blind to the impacts of our actions. So, while our workshop remains quiet today, the work is far from paused. We are refining our designs, we are testing our algorithms, and we are preparing. Because when the time comes to launch our next vessel, we know that it carries more than just microchips and solar panels. It carries our collective commitment to watch over the waters that sustain us all. Thank you for sharing this time with me today. If you have enjoyed our exploration of marine conservation and the robotic technology we build to support it, please consider subscribing to the Kalopa Mission Control Podcast on your favourite platform. And if you know someone who feels that same inescapable pull toward the sea, I would be deeply grateful if you shared this episode with them. Until we meet again, may your horizons be clear, the wind be fair, and the seas be kind. Goodbye for now.